Hello everyone, welcome back. In this video we are going to do exercise 6.2 of lines and angles. We have already done the concepts which we are going to use in this exercise. So I have already shared that video in the description. If you have not seen that video, you can check out that video first and then you can continue with the exercise. So the first question of this exercise is, in figure find the values of x and y and then show that AB is parallel to CD. So this x and y we have to find, plus we have to show that AB is parallel to CD. So I have already told you in this type of questions, first of all write the given things. So here nothing much is given, only these two lines plus this transversal is given to us. So transversal, its name is not given, so let's name it as OP. So we can write lines AB and CD and OP transversal. Then next point is to find. So we have to find the values of x and y. So we can mention here x and y. So here along with to find we have to write to prove also. So in this step only we can mention to prove AB is parallel to CD. So these two things we have to do in this question. So let's start with the solution. So here let's name these 2 points as R and S. So in this figure we can see we have these two angles whose values are given. So we can mention, so in given we can mention this thing also, angle ARO is equals to 50 degree and angle CSP it is equal to 130 degree, because these two angles are given to us, ARO which is equal to 50 degree and CSP which is equal to 130 degree. Now if we see angle CSP and angle RSD, these two angles CSP and RSD, which means Y. So these two angles are forming a pair of vertically opposite angles, and we have already done in theorem 6.1 that vertically opposite angles are equal to each other. So we can mention angle CSP and angle RSD, they are forming a pair of vertically opposite angles. Therefore angle CSP is equal to Y, because vertically opposite angles are equal. So we have to write full theorem. So I am only mentioning theorem 6.1 that pair of vertically opposite angles are equal to each other. Therefore Y is equal to, because we know the value of angle CSP which is 130 degree. So here we can mention because angle CSP is equal to 130 degree and this is already given to us. Now we know the value of y. So let's find out the value of x now. So here we can mention y is equals to 130 degree. Now let's find out the value of x. If we see angle ARS and ARO, these two angles, they are forming a pair of adjacent angles such that 50 plus 180 is equals to 50 plus x is equals to 180 degree, because these two, they are forming linear pair. We can write now, see if this is one line OP, here I'll draw OP is one line, and RA, this is a ray. So here this is X and this is 50 degree. If we just rotate this line, so similar figure we will get. So angle ARO and ARS, they are forming a pair of adjacent angles sharing a common vertex and common arm AR, hence their sum is equal to 180 degree according to linear pair axiom. So this is what we are going to use here. Linear pair, this concept we have already used in while doing the questions of exercise 6.1. So same concept we are going to use here also. So now we can mention angle ARO, see, ARO plus angle ARO ARP is equals to 180 degree. So reason we can mention linear pair or linear pair axiom, because on line OP, ray AR stands forming a pair of adjacent angles, and this type of scenario it is known as linear pair axiom. So ARO it's equal to 50 degree and ARP it is equal to X. So 50 plus X is equals to 180 degree. Now we need to find the value of X. So let's write X on this side and shift 50 on other side. So this is plus 50, on changing the side it will be changed to minus 50, because plus on changing the side is changed to minus. So 180 minus 50 is equals to 130 degree. So we got the value of X also equals to 130 degree. So here we can write the value. Now, so first thing it's done to find the values of X and Y. We got the value of X also equal to 130 degree and we got the value of Y also equals to 130 degree. Now we need to prove that AB is parallel to CD. Now if we observe X and Y, we can see that X and Y, this is X and this is Y, they are forming a pair of alternate interior angles. So X and Y are forming a pair of alternate interior angles. So alternate interior angles I have already explained while doing the concepts, that interior angles on both sides, see this is also inner angle, and if you see this is also inner angle and opposite side of the transversal. This angle on left side of the transversal and this angle is on right side of the transversal. So they are forming a pair of alternate interior angles and they are equal also. So according to theorem 6.3, which we have already done, 6.3, if a line or if a transversal, so this reason we have to mention, if a transversal intersects two lines such that the pair of alternate interior angles is equal, then the two lines are parallel to each other. So these two lines. So we can mention therefore AB is parallel to CD. See, this is transversal OP and it is intersecting these two lines, and now we can see also that the pair of alternate interior angles is also equal. Therefore AB is parallel to CD as per theorem 6.3. I have written the full statement also. So this is also proved. Now we can write hence proved. We have found the values of X and Y also and we have proved this also. Now let's do the next question. In question number 2, it's given in figure, if AB is parallel to CD, this line AB it is parallel to CD and CD is parallel to EF. CD is parallel to EF and the ratio of Y is to Z is 3:7. We have to find the value of x. So let's proceed the same way. First of all, write the given thing. It's given AB is parallel to CD, CD is parallel to EF, and ratio of y is to z is equals to 3:7. To find is x. So solution. Now we know AB is parallel to CD. We can write AB is parallel to CD. We can name it as point number 1, and CD is parallel to EF. Let's name it as point number 2. So from first and second, we can see, because AB is parallel to CD and CD is parallel to EF. See, lines parallel to same lines, these two lines are parallel to same line CD are parallel to each other, which means AB is parallel to EF as per theorem 6.6. We have already done this theorem. So AB is also parallel to CD and EF is also parallel to CD. So lines parallel to same line are parallel to each other. So we can mention AB is parallel to EF. So there we can mention the reason also. Lines parallel to same line are parallel to each other. So this is as per theorem 6.6. We have already done its proof also. So that result we are using here. Now we know AB is parallel to EF. This AB is parallel to EF. From here we can use one pair of angles, X and Z. So if you observe, you can see X and Z, they are forming a pair of alternate interior angles. See, these two angles are on the inner side of the lines, parallel lines, and on opposite side of the transversal. X is in left side of the transversal and Z is on right side of the transversal. So we can mention, so this we have already mentioned, AB is parallel to EF. So therefore X and Z, we can mention they are alternate interior angles. Therefore X is equals to Z. Now see, ratio of y is to z is given to us. So since ratio is given to us, I have already explained in exercise 6.1 also, whenever ratio is given to us, we can assume. So after this we have to assume. Now here we can mention, because we have found out x is equals to z, because they are forming a pair of alternate interior angles and alternate interior angles are equal to each other. Now ratio of y is to z is given to us. So whenever ratio is given to us, we have to assume the values. Let y is equals to 3x, or in terms of a we will assume 3a, and z is equal to, we will name it as point number 3, because point 1 and 2 we have already used at the starting of the question. So this point we can name it as point number 3. Z is equals to 7a, because this ratio is given 3/7. So in front of y 3 is written and in front of z 7 is written. So y is equals to 3a and z is equals to 7a, and ratio, because it's the reduced form of some numbers. So like if y is equals to 3a and z is equals to 7a, so this common number or common multiple, it will get cancelled and we are left with smallest reduced form. So that's why we always assume it as 3a or 7a. Directly we cannot assume y is equals to 3 and z is equals to 7, because ratio is given to us, reduced form is given to us. Now we know z is equals to x, so here we can mention, therefore can mention x is also equals to 7a, so we can mention from point 3, or we can also mention because x is equals to z. We have already proved this thing. Now we have got the values of x and y. Now we know AB is parallel to CD because this thing is already given to us. AB is parallel to CD. And if we see x and y, they are forming a pair of co-interior angles. See, they are on the inner side of the parallel lines, plus they are on the same side of the transversal. So co-interior angles also I have explained you, x and y. Therefore x and y, they are co-interior angles, and co-interior angles are always supplementary. Supplementary means their sum is equal to 180 degree. So therefore x plus y is equals to 180 degree. The value of x we know it's 7a, value of y is 3a. We just have to substitute the values of x and y, is equal to 180 degree. 7a plus 3a, 7 plus 3 is 10. So 10a is equals to 180 degree. This 10 and a, they are getting multiplied. So we need to find the value of a. A will keep on this side and 10 will shift to other side. So here they are getting multiplied. On changing the side, 10 will get divided by 180 because multiplication on changing the side will be changed to division. So this 0 and this 0 will get cancelled. So we got the value of a is equals to 18. Now we know the value of 18, we can easily find the value of x because the question is to find x. So x is equals to 7a, 7 into a. So a is 18, we can substitute the value of a as 18 and we can do its multiplication. So 7 on multiplying with 18 will get 126. So x is equals to 126 degree. So we don't have to find the value of y or z because in question it's mentioned we only have to find the value of x. So it is found now. So let's do the next question. In question number 3, this figure is given to us and it's given if line AB is parallel to CD. So this is AB and this line is parallel to CD. EF is perpendicular on CD. This is EF, this is perpendicular. So this angle is 90 degree, this is a sine of perpendicular and the value of this is 90 degree. Angle GED, I have mentioned, this is equal to 126 degrees. So we have to find angle AGE, this angle GEF, this one, the inner one, and angle FGE, this angle. So these three angles we have to find. So we will start in the same way like we are doing earlier. First of all, we have to mention the given things. So in given you can mention AB is parallel to CD and these things you can mention till here. Then to find, we can mention this step to find angle AGE, angle GEF and angle FGE. Then directly I am going to start from the solution. Now it's mentioned AB is parallel to CD. It's already given. We can mention the reason also. It's given. Therefore, angle AGE, it is equal to this angle. So I have marked with red color angle AGE. It is equal to angle GED. Why these angles are equal? Because if you see these two angles, they are forming a pair of alternate interior angles. And we have already done the theorem that if these two lines are parallel to each other, then a pair of alternate interior angles are equal to each other. You can see these two angles are on the inner side of the parallel lines plus they are on the opposite sides of the transversal. This angle is on left side of the transversal and this angle it is on right side of the transversal. So these two angles I have marked with red color. So these are forming a pair of alternate interior angles. So AGE, therefore angle AGE, it is equal to 126 degree. So here also we can mention, because angle GED it is equal to 126 degree. So therefore AGE is also equal to 126 degree. So here we have found the value of AGE. You can write here it is equal to 126 degree. Now let's move towards the next angle, GEF. So we can see angle because we have been given the value of angle GED. So I can start from here, angle GED, see this one GED, this 126 degree which I have marked with red color. It is equal to 126 degree. Now GEE, if you see it carefully, you can see, if you observe, you can see GED, it's sum of two angles, this one plus this one. If you add this complete angle, it is becoming 126 degree. So let's break down GED into its two angles. So the first one is angle GEF, this one GEF plus angle FED, so equal to 126 degree, because it's given. See, I have done, see this angle is given to us, GED. So here is one perpendicular, it's given to us. So if we add these two angles, this one and this one, we will get this complete angle. So that's what we have done. This angle, we have broken it down into its two angles, first this one and second one this one. So we are adding this and this, we are getting complete this angle. So here we can mention the reason also, because angle GED, it is equal to angle GEF plus angle FED. So this reason we can mention. I have already shown how GED is equal to the sum of these two angles. See, we are just adding these two angles. This thing we have already used in previous exercise also. Now GEF, we don't know the value of GEF, we have to find the value of GEF. So we can write GEF as it is plus FED. FED is this, it is perpendicular, or it's a 90 degree. This is a sine of 90 degree. So the value of FED, it is 90 degree. We can substitute the value of FED is equals to 126 degree. So angle GEF, we will keep this on this side and 90 will shift on other side. So 126 plus 90, on changing the side it will be changed to minus 90. So 126 minus 90, angle GEF. So it is equal to 36 degree. So the value of angle GEF is equals to 36 degree. We can write the value also 36 degree. Now we need to find the value. This also we have found, which is equal to 36 degree. Now the last angle is FGE. FGE, this one which I have marked with blue color. So all the concept which we have used in previous exercise also, along with the concept which we have learned while doing this exercise. So all concepts we can apply here. Now these two angles, this one and this one, these two angles, they are forming a pair of adjacent angles such that their sum is equal to 180 degree, because AB is a line and GE is a ray which stands on this line. So the pair of these two angles their sum is equals to 180 degree as it is a linear pair. So this concept also we have used in previous exercise. I'll just see, we just have to rotate it. So if you rotate, you will get, this is a line AB, so BA will get here, and this is EG, this G, and here it is E. So like this it will become, so one angle is AGE, this one is equals to 126 degree, and this we have to find because this is the value of that. So the other one AGE, it is equal to 126 degree, and FGE, so this is FGE, or we can mention here F also, because F, if we are producing, it's meeting on point B, so you can mention FGE also and BGE also, the angle will remain same. So like this we'll get the figure. See, these two angles, they are forming linear pair, so this result we are going to use here. So we can mention angle AGE plus angle AGE plus angle FGE is equals to 180 degree. Reason we can mention linear pair, you can see these two angles, they are sharing a common vertex G and common arm GE, so that's why they are forming linear pair. Then AGE, we know the value of AGE, which is equal to 126 degree, plus angle FGE is equals to 180 degree. So we need to find the value of FGE. We'll keep FGE on this side and 126 will shift to other side. So plus 126 on changing the side will change to minus 126 degree. Now we can do the subtraction. So angle FGE is equal to 54 degree. So angle AG is equals to 126 degree, and the value of GEF is equals to 36 degree, and FGE is equals to 54 degree. So this exercise, it has total of 6 sums, 3 questions we have completed, and the next 3 questions I'll continue in the next video. Thank you so much for watching the video. See you in my next one.